Hello engineers, welcome to the new video of the course, and in this particular video we are going to understand the concept of Bohr's law. Okay, so basically if you search on internet about Bohr's law you will get a good hefty amount of definition, but I had tried to explain this particular entire concept in a very clear and precise way. Okay, so first of all we will read each and every point and we will try to understand each and every concepts one by one or step by step. Okay, great. So let's start with the sentence as mentioned over here, in an isolated atom. Okay, so let me just highlight this particular word, isolated atom. So what is the meaning of isolated atom? Okay, so for that let me proceed further and let me just explain you this particular entire thing. So let's assume that I have certain material. This material can be anything. It can be made up of wood, it can be a nickel, it can be an iron, it can be an aluminium as well. So it can be any material. What I'm doing over here is that we all know every material has n number of atoms in it, right? But what I'm doing, I'm actually extracting only one atom from that particular material. Okay, I'm extracting one atom from that particular material. That means what? I am actually isolating this particular atom, right? I'm actually isolating this particular atom from the other atoms. Okay, I hope you are able to understand this particular point, right? Again, I will repeat. What I'm doing over here is that, I'm taking certain material. Okay, as of now, this is not of great concern for me. Like what is this particular material? It can be a wood, as I mentioned. It can be a wood, it can be an aluminium, it can be steel, iron, it can be anything, right? And we all know every material has infinite number of atoms in it, right? So what I'm doing, I'm just extracting one atom, okay, and I'm studying it. Okay, I'm extracting one atom and I'm studying it. And when I say that I'm extracting that particular atom, right? When I say that I'm extracting certain atom, that means what? That means I'm isolating that particular atom. I'm isolating that atom, right? I'm isolating that atom from the other atoms. Okay, I hope you are able to understand this part. That means this particular atom, it is isolated from the rest of the atom. Okay, and why I'm doing this? Because I want to analyze, or because I want to study this particular atom alone. Okay, and why I'm extracting? So that I can analyze, or rather I can study this particular atom. Analyze, or rather I can study this particular atom. Okay, so let me just give you one example, if you find it little difficult to understand. So during COVID-19, I hope you all guys know, or even you might have suffered, or you all guys might have infected with that particular virus as well. So during COVID-19 we were using this particular word rigorously, right? Some patient has to keep in isolation, right? Few of the patient needs to be kept in isolation. What does that mean? So let me just write over here. So during COVID-19, the infected patient, right? So the infected patients, they were isolated. That means they were kept in certain rooms, in one single room, and then they were kept under the observation, right? That means the doctors were studying that particular infection. Okay, on the person, like the person who were infected by that particular virus. So doctors were analyzing that particular person, or rather doctors were learning that particular or studying that particular virus, right? Great. So that means what? We are doing the same, we can actually apply the same idea, or rather we are actually doing the same thing with atom. What we are doing, we have n number of atoms. Out of that we are just taking one atom, or rather we are just extracting one particular atom and we are studying that particular atom. Okay, I hope you are able to understand this particular part. So this is the meaning of isolated atom. That means a single atom. Okay, I know, just to make the things little clear, I am explaining in depth. Okay, I hope you are able to understand this. A single atom. Great. Because this is very, very important, in future when we are going to study the energy band diagram. So there, I will explain you that why exactly we are studying the isolated atom, and how exactly it fails in certain scenarios. Okay, so that's why I'm explaining it in little detailed way. Okay, so in a single atom, or rather in an isolated atom, the energy of an electron depends on the orbit in which it is revolving in. Okay, I know you all guys understood nothing by reading this particular sentence. Okay, don't worry, I'm here to explain you each and everything. Okay, but before that, let me just give you a rough idea about an atom. Okay, so I'll just draw over here very roughly. So let's assume this is my atom, right? We all know atom has certain orbits or shell, right? Something like this. So this is shell 1, this is shell 2, or maybe orbit 1, orbit 2, and in between there is one nucleus. Okay, let me take certain different color. In between there is one nucleus, right? Nucleus, let me write it properly. Yeah, in between there is one nucleus. We all know nucleus has protons and neutrons, right? Protons is positively charged. Protons is positively charged, right? Whereas neutrons are neutral. Okay, so don't worry about that. And we all know that the electrons revolve around this particular nucleus. So I'll just draw very roughly. So these are few electrons present in the respective shells, and they will revolve around this particular nucleus, right? So we all know electrons are negatively charged. Okay, electrons are negatively charged. Great. So this was all about the basic about the atoms. Okay, I believe that you all guys have a good idea or good understanding about it, because you know this is the prerequisite of the course. Obviously with conductors, I hope you all guys are quite good in physical chemistry, and when it comes to physical chemistry, I'm not assuming that you should know or you should have a in-depth idea about thermodynamics and all of those particular concepts. No, basic idea about what is atoms, what is nucleus, what is proteus, what is neutrons, what is K shell, L shell, M shell, what are electrons, how these electrons revolve around the nucleus. These are the only concepts which are required for this particular course. Okay, and I believe that you all guys have a good idea about it. Okay, great. So as I mentioned that this is my atom. Okay, here I had drawn it properly, so you can clearly see this is my N means nucleus. So this is my nucleus. Okay, and you can clearly see this is my orbit 1 or shell 1. In some of the books you will get orbit 1 or orbit. Some of the books term it as orbit, whereas few of the books term it as shell. So both are correct. Okay, so this is my orbit 1 or shell 1. Just a second. Okay, yeah, so this is my orbit 1 or shell 1, and this is my orbit 2 or shell 2. Okay, and there is certain capacity that this particular orbits can hold the electrons. Okay, so generally if you I don't know if you all guys know this or not, so K shell has tendency to hold around 2 electrons, L shell has tendency to hold around maybe 8 electrons. Okay, and this number keeps on increasing as we move further and further, right? So there is, as you can see, each and every shell has certain capacity to hold certain electrons, right? And this number keeps on increasing as we move away from the nucleus. Okay, great. I hope you are able to understand this particular concept up till here. Okay, so now let's proceed further, and for time being we are assuming that as I had already mentioned that this is a random material, and obviously this is going to be a random atom, right? It can be any atom. Okay, that is not a big concern for us. Okay, so let's assume for time being that both of these shells has 2 electrons. Okay, so maybe this is electron present in the first shell. I mean, these are the 2 electrons present in the first shell. Okay, and in the second shell as well we have, I'll just draw it somewhere over here. Yeah, in the second shell as well we have 2 electrons, maybe somewhere over here. Okay, I hope you are able to understand this. Okay, great. Now what we'll do, we'll try to understand each and everything step by step. Okay, so now let me proceed further, and we will first try to analyze the innermost shell. Okay, so as I mentioned that the innermost orbit has 2 electrons. Okay, for time being we will assume that this is my electron A. Let me write it with some different color. Yeah, so let's assume that this is my electron A, and let's assume, let me just write it somewhere over here. Yeah, let's assume that this is my electron A, and let's assume that this is my electron B. Okay, so what Bohr's law states is that the energy of electron A is equivalent to the energy of electron B. Okay, and let's assume that the the energy of electron or the innermost shell has energy of around 1 electron volt. So let's assume that the energy of this particular shell or orbit, it is 1 electron volt. Okay, this is again a random number. I had just taken or assumed a random number so that it would be pretty easier for us to understand this particular concept in clear cut way. Okay, great. So again I will repeat what Bohr's law states, that the energy of electron A and the energy of electron B, it is same, and that is how much? That is 1 electron volt. that is 1 electron volt. Okay, if you look very clearly, this is what it is stating. It states, in an isolated atom, the energy of an electron depends on the orbit in which it is revolving in. So as this particular electrons, they are revolving around the nucleus, okay, and this is the innermost orbit, right? So the energy of this particular orbit, it is fixed, that is 1 electron volt. I will come to this particular point, that why exactly it is fixed, don't worry about that. But the energy of this particular electron, it is fixed, that is 1 electron volt, and therefore if you try to carry out the energy of these electrons, so you will get the same energy for both of these particular electrons. Okay, similarly if you come over here, let me proceed further. Yeah, and let's suppose if I'm drawing these particular electrons over here. So now this time I'm drawing the electrons of the outermost shell, that is the shell 2 or the orbit 2, and for time being, again we'll consider some random electron. So let's assume that this is my electron C and this is my electron D. Okay, by the way, this is not the type, I'm just giving the name of this particular electron so that it would be pretty easier for us to understand this particular concept. Okay, so what it states is that the energy of electron, the energy of electron C, is equivalent to the energy of electron D. And let's assume that the the energy of this particular shell or this particular orbit, it is 2 electron volt. Okay, again this is the random number. Okay, so that means I'll write over here the energy of electron C is equivalent to the energy of electron D, and that is equivalent to how much? 2 electron volt. That's correct. Okay, so with this two particular idea which the Bohr's law has proposed, we can conclude one more thing, and that is the energy of electron AB, it should not be equals to, or rather it is not equals to energy of electron CD. That means what? The energy of K shell, okay, or the innermost shell. Okay, so K shell is the innermost shell. Okay, so let me just show it to you what exactly a K shell is. So the innermost shell, it is known as K shell. So this is my K shell, this is my L shell. Similarly, if there is one more orbit over here, so that would be M, K, L, M, N. Okay, so it keeps on increasing. Okay, I hope you are able to understand this. Similarly over here, this is my K shell, this is my L shell. Okay, great. So what does that means? That means, let me just erase this. Okay, so that means I can conclude two things over here, that is the energy of electrons A and B, okay, is not equals to the energy of electron C and D. Okay, and we can clearly see over here, this is because the if you look over here, the energy of this particular orbit or this particular shell, it is 1 electron volt, whereas this particular shell, it is 2 electron volt, right? So this is because I'll just write over here the energy is 1 electron volt, and over here the energy is 2 electron volt. Okay, I hope you are able to understand this. Great. And we can write one more thing, that is energy of K shell is not equals to energy of L shell. Okay, so these are the few of the things that we concluded over here. These are the few of the things that we had concluded over here. Okay, I hope you are able to understand this particular point up till here, and let me add one more point over here. I mean, not one more, but few of the points that we had concluded. So this would be our conclusion. So let me add few of the points over here. That will be our conclusion. So let me just write over here the conclusion of this discussion. Okay, so the conclusion of this particular discussion is that my energy of K shell is not equal to the energy of L shell. That's great. Secondly, the energy level of each shell is different or discrete. Okay, second point is, so this was my first point, this is my second point. let me change the color, the energy level of each shell or orbit is different or discrete. That means they are not continuous. What does that mean? Just a moment, let me just finish this. Okay, that means, see, if you look over here, the energy of the innermost shell, it was 1 electron volt. The outermost shell, the energy was 2 electron volt, right? So if you look over here, the energy is straight away jumping from 1 to 2. There isn't any continuity, right? Like if this was 1 electron volt, this is directly 2 electron volts. Okay, what is the meaning of continuity? So instead of 2, if let's suppose if it was around maybe 1.01 electron volt. Similarly, if let's suppose if there is M shell, and let's assume the energy of this particular shell, it is 1.02 electron volt. So you can clearly see there is certain continuity, right? From 1 it is incrementing by very small number, that is 0.1 electron volt. Similarly, if it is moving further, so M shell has energy of around 1.02 electron volts, right? So you can see a certain continuity, right? But over here you are not able to see continuity. Rather, the energy is how much? The energy is 2 electron volt, okay, of L shell. Okay, again I'm just mentioning that this is the random number, this is the random atom. Okay, as such there isn't anything fixed over here. Okay, the energy and the energy of each and every orbit is different for each and every atom. Okay, great. And one last thing to conclude, that is, just a second, third point. What does that mean? That means, let me just write over here, that is, every orbit has discrete energy. Every orbit has discrete or different energy. Discrete energy. Okay, so now I know most of you guys will say that these 2 points are similar. No, they are somewhat similar, but this point will clearly indicate that the energy level of each shell or orbit is different. This point will clearly indicate that the electrons are present in the orbit, right? Don't worry about how many electrons are present as of now. Just assume that there are few electrons present in every orbit. So the electrons which are present in the same orbit have same energy. Okay, this is what it tries to indicate, right? This is what it tries to pacify. Okay, and whereas this particular point, it indicates that the energy is different, or it is totally discrete for the different orbits. Okay, I hope you are able to understand this particular point. Great. So this was all about this particular session. Again, we will quickly revise the concepts that we had discussed. Okay, so in an isolated atom, that means in a single atom, the energy of an electron depends on the orbit in which it is revolving in. That means what? If the electron, it is revolving in the innermost orbit, it has certain different energy, whereas if the electrons are revolving in the outermost orbit, it has certain different energy, and both of this particular energy, it won't be same. Okay, so as I mentioned that the isolated atom means a single atom, right? Then I also show you the two shells over here. Again, this is the random atom, and we are assuming that there are 2 electrons present in each and every shell. Okay, and if you look very clearly, the energy of electron A, so we just assume 2 random electrons, electron A and electron B. So energy of electron A is equivalent to energy of electron B, and we also assume that the this particular shell, that is the innermost shell, has a fixed energy level, that is 1 electron volt, and as you can see, I had clearly written over here. So the energy of electron would also be 1 electron volt. Okay, similarly, if you move further, that means to the outermost shell, again we had just taken a random number, that is the outermost shell has the energy of around 2 electron volt, and you can clearly see the energy of electron C. So again we had assumed this electron as electron C and this electron as electron D. So it has fixed energy as 2 electron volt. Okay, and with this we can conclude 2 things, that is the energy of K shell, that is the K shell which is holding electron A and B. Okay, and energy of L shell which is holding electron C and D, they are not at all same. Okay, that, and you can clearly check over here, the energy level is totally different. Okay, So these are the conclusions which we can draw from here. Okay, these are the 3 important conclusions which we can draw with our discussion. Okay, so this was all about this session, and let me just give you one question, and that question is why the energy of each orbit it is fixed. Like if you see, the innermost orbit or the innermost shell has energy of around 1 electron volt, whereas the outermost shell has the energy of around 2 electron volt. So why it is fixed, why it is constant? Okay, so make sure to just apply your logic. It's fine even if you are wrong. In the next video we are going to work upon it, and we will try to deduce certain reasons, okay, due to which this energy is fixed. Okay, so I believe that you understood each and everything that we had discussed in this particular session. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys, you please make sure to ask me in the communication section. I will surely help you out there. Thank you.
Bye.